Alright, good morning. How's everybody doing? Doing good. Good to hear it. Alright, any questions before we get started? Zoom is not letting me move my Zoom window. So let me try this again. There we go. Alright, well, let's talk about the upcoming ODP. And then we'll go ahead and we'll talk about fgets and string length and things like that. Any lingering questions on ODP 411B? It seemed like there was a lot of confusion about how to check the return value from scanf and so on, but I looked last night, it looked like most people had figured things out. So but if there's questions on that, we can talk about it here. Alright, and there's only 14 people in the class for some reason. I'm taking attendance now. I'm not going to count it yet, but I am recording attendance. So so if attendance is habitually falling off, I will start doing something different. Do we need to do the pipes and the number in parentheses visual for homework 4? Absolutely. Yeah, homework 4 is exactly like homework 3 except for those differences noted in the beginning. And printing those pipes is really just a for loop. If you do printf without a \n, things will print side by side. And then just do a parentheses %d close paren \n and replace the %d with a number of sticks. Alright, well let's take a look at ODP 412. Sorry, 413. Canvas said 412 originally. I've changed it to 413 and sent a note about that. So this is ODP 413. So 413, you're writing another function that has nothing to do with the previous ODPs you've done. There's no input, there's no output, there's no scanning, okay? This is a function that takes in a character array and counts the number of lowercase e's that we find in that array, and then returns that count. So the prototype is count e, takes a character star, that's a string, returns an int. Okay, same prototype as the other functions you've been writing. But this one should iterate over all the characters in this string and count the number of times you find a lowercase e, keep that running count, and then return that count. If there's no e's in the string, return a 0. If there's no characters in the string, return a 0. If the string has 5 e's somewhere inside it, return the number 5. Alright, so write your function, write your own test bed. I'm thinking of it as main.c here. Compile it using this, right? Compile your main.c and your count function .c into an executable, run that executable, test your function thoroughly. Once you're sure it works, go ahead and build it with the test bed by using this command. So assemble it with /temp odp413 main.o. I'm calling the executable here count E, and then say assess count E and the source file name, and that should give you 60 out of 60. All right, so to do this, we need to know a little more about strings. So suppose we have a string whose length is 60. So we've defined it as a character str bracket 60. And suppose we do, you know, an fgets. And we read some characters from the user into this string. And we want to know how many characters are in that string. There's a function called string length. You pass string length a char star, right, a pointer to a character, which is what this is, and it returns an integer. And that integer is the number of characters in the string. All right, so when you want to figure out how a function works, you want to understand its behavior better, write some code. Okay, so let's write some sample code. So let's just hardwire an argument. Okay, so we'll just call string length with the argument hello, and we'll save the return value in this integer len, and we'll just print out the value of len. All right, now if I try to compile this, I'll get a warning. Okay, pay attention to your warnings. Paying attention to these will save you pain and suffering down the road. Okay, my program will probably still run, but pay attention to the warnings. What's the warning saying? Incompatible implicit declaration of built-in function string length. Well, what does that mean? I don't know, but you know, if I look at the next thing, there's a note and it says include string.h. Oh yeah, I forgot to do that. Okay, so anytime we use these string functions, string length, string compare, and so on, we need to include string.h. All right, and that's mentioned in the README file, right? If you use string length, you want to include string.h in your count.c file. All right, so if I include that, I should be able to compile without errors or warnings. And then if I run my test program, it tells me string length returned 5. All right, why is it 5? H-E-L-L-O, 5 characters. If I put 2 spaces in the beginning and 2 spaces at the end, it returns 9. So string length does not treat spaces any differently from any other character. If I put funny characters in the middle of my string, so I'm putting in a control A and a control B, these are characters with ASCII codes 1 and 2. So I have H, E, control A, control B, L, and O. 6 characters. 2 of them are really bizarre characters, but they get counted just like any other character. If I throw a couple of new lines in the middle, so HE, new line, LO, and I run that, string length is 6. Why? Because there's 6 characters in the string. HE, new line, LO. So string length does not do a whole lot of fancy stuff. It counts the number of characters. Yeah, so someone's commenting in chat that they didn't realize you could still run your code with warnings. Usually if you only have warnings, you will get an executable program and you'll be able to at least start running it. And a lot of times the warnings are benign, but more than a few times the warnings leave you with a situation where sometimes your code will work, sometimes it'll do something different, which is why I tell people make sure you fix your warnings. Alright, so string length. What's it doing? It's just counting. Okay, so if your string is HELLO, this is string element index 0, index 1, index 2, index 3, and index 4. There's also a null terminator at the end of your string. And that null terminator would be the next element in the array. That would be at index 5. But string length would be 1, 2, 3, 4, 5, the number of characters. So what's possibly interesting to note here is that this last character always has the index of string length minus 1. And the null terminator always has the index of string length. Those can be useful sometimes. Alright, and new lines, funny ASCII characters, none of those things affect your count. The only thing that affects your count is a null terminator. Now if I were to put a null terminator in here after the E, string length would change to 2. And this is this business of C not having an inherent length to arrays, so we use this trick, which says as soon as you find a null terminator, that's where the string ends. Right, but anything else just gets counted. All right, so that's string length. So let's go back to let's use fgets. So let's prompt the user and let's say fgets, and we'll read into our string, which I haven't named it, so I'll call it string 120 standard in. So let's declare a string. All right, so we'll ask the user for a line. We'll call fgets to read in that line, and then let's find the length of that line, and then let's print it out. Alright, so enter a line, let's go back with hello, and string length is equal to 6. We just did painstaking detail where I said that for hello the string length would be 5. Why is the string length suddenly 6? Yeah, there's a new line character at the end. So fgets, terminates when you hit the enter key. That enter is basically a new line that gets added to your string by fgets. Okay, it's just a feature. It's what it does, and you need to know that because otherwise your string length ends up being off by 1. All right, so if I run this and I just hit an enter, which should be an empty line, string length is 1. because my line is not really empty. It's not quote, quote. It's quote, \n, quote, right? \n is how we say the new line character. So it has that one character. All right, suppose I change fgets and I tell it that there's only 5 spots available in my character array. So I enter a line and I say hi, and string length is 3, hi followed by a new line. All right, if I say hello, what do you think string length is going to return? And think in terms of memory and new lines and null terminators. So we have a vote for 5. Any other votes? Another vote for 5. 5 is winning. Any other votes? Six. Cool. Anyone think it will open a black hole and destroy the entire galaxy? Yes. 1 vote for the black hole. Yeah, but if that happens, we'll never know it. Well, maybe we will. Alright, ready? String length is 4. What the heck? Alright, why is string length 4 when I clearly said that there was spot for 5 characters in my string? Because strings always need to be null terminated. And so if str has 5 spots, like this, and I type in HELLO followed by a new line, well, this takes the H, this takes the E, this takes the L, this takes the L. It needs to store a null terminator somewhere, so it stops reading input here, and it stores the null terminator right there. And this is what my string str looks like when I look at string length. I get 4. Now this usually doesn't concern us, because usually we're making our character arrays big enough that we can read an entire line. But in cases where the input is longer than the size of the buffer that we specified, this can be startling. And I'll show you an edge case where I've seen this really cause trouble. If somebody thinks they only want to read 1 character, I've seen students declare a character array of length 1 and then use fgets with an argument of 1 and say, hey, just read 1 character into my string. And this doesn't quite create the black hole that destroys the universe, but almost, because when you run this, it doesn't wait for any input at all. It just comes back and it says string length is 0. The reason for that is if it reads even 1 character from standard in, to store that character followed by a null terminator would take 2 character positions in the array. And I've just told fgets there's only 1 spot available. It uses that for the null terminator, which means it doesn't bother reading anything from standard in. And so you think that it's going to wait for a character input here, and instead your code just runs and your input is empty, and that can be really confusing and bizarre. But like I say, usually, we make these things big enough that we don't run into these kind of end-of-line conditions. All right, so let's dig deeper into fgets. So let's look at looping with fgets. So normally we just call this function, and it loads its input into this character array, and we do something with it. But fgets actually returns a value. It returns a char star. And so if you look at the manual page for something, usually at the bottom you'll find a section that says return value. And this manual page, covers a bunch of functions. So it covers fgetC, fgets, and so on and so forth. So if you look at the return value for fgets, it says on success it returns s, where s was the argument that you passed to fgets. It's a string you were asking it to load into, and it returns that string back to you on success. Okay? But on an error or end of file, fgets returns null. So let's write a program that repeatedly asks you for input, reads it in, and prints out the length of the input line. Let's make a loop around this. So I want to save the return value from fgets, so I'm going to call something like, return value equals. And in this case, instead of being an integer, return value is going to be a char star. Right? Why? Because that's what the manual page said fgets returns. So I'll save the return value from fgets in this variable. And I'll say, well, the return value is not equal to null. And I'll calculate the length. I'll print out the length of that line. And then I'll repeat these two things at the bottom of my loop. Alright, so pretty standard while loop here, right? I'm going to prompt the user, call fgets, and then as long as it did not return null, I know I didn't hit the end of the file, so I'll calculate the length of that input string, print it out, and then I'll prompt the user again, call fgets to get a value, save the return from fgets and return value, go back to the top of my loop. So this I can run and I can say enter a line, I'll say hello, and it tells me string length returned 6. If I hit an enter, string length returned 1. If I say goodbye, string length returned 8. Okay, when I want to exit this loop, what do? Control D. Okay, or sometimes this is written as a *D. So Control D means hold down Control, and while you're holding it, press D. And that's how we signal to most things in Unix that we're at the end of the input. So if I hold down Control and press D, my program exits. Okay? It doesn't exit because I hit Control C, right? If I hit Control C, my program also exits. But that's different. That's interrupting my program. So let's put something down here. Let's just print something out. Let's just say goodbye. So there's hello. If I hit Control D, it says goodbye. Right? And that's totally different from Control C, which just says, interrupt the program. So Control D, we're asking the operating system to indicate to fgets that we've hit the end of our input, the end of file. And this call to fgets will return a null to let us know that's what happened. Alright, and you'll usually see this written more succinctly like this. right? So here's a loop where the condition in our loop, right, every time we get to the top we have to evaluate this condition, which will say, well, let's take null and see if it's different from this right-hand side. Well, to find the value of this right-hand side, it has to call fgets. So this will make a call to fgets, which will read from standard in, take the return value, store it in str, and then compare the result from fgets to null. And if it's different, then we'll calculate the length, print it out, prompt the user again, go back up here. So exactly the same behavior, but a more concise way of writing the loop. I misspelled cool. All right. So question, why the two different declarations for a string? Let's see. Did I delete it? Oh, the return value. So I was just using the manual page, which was telling me that that the fgets function returns a char star. All right, this gets into a subtle point, so it's good to bring that up. So let's go back to where we had the return value. So yeah, my character array, remember, I want to actually set aside storage to store 120 characters. And so this thing we were talking about most of yesterday was this idea that this is a simple declaration that return value points to a character. Return value will point to a set of characters in memory. But this is that same declaration plus a request that the compiler set aside storage for such an array, and that it make that storage at least 120 characters long, and that it set str to the address of the first piece of that storage. Right? So since I'm planning to use fgets as an argument, str as an argument to fgets, and I'm going to say read some input and store it in str, right? I need to have space allocated for that. That's why I declared str like this. Say that it's a pointer to a character, and it should set aside 120 locations, and str should be the value of the address where that first character is stored. But the fgets function, we're told it returns a pointer to a character, and all we care about is that pointer null or not? So I'm just declaring a pointer to a character. Now, if I try to do something like this, right, I'm saying again, return value is a pointer to a character, but I'm allocating 10 bytes of memory somewhere that I'm not going to use, and I'm giving return value an actual initial value, which is the address of that block of memory that's been set aside. And I'm not going to do anything with all of that, right? Because down here I'm going to change what the value of return value is. It's going to be whatever the address is that comes back from fgets. And so this is a little worrisome, right? Somebody looking at your code would not know what was going on here. And depending on your compiler flags, your compiler may have similar suspicions, right? And in this case, it'll actually give you an error and say this is an array type variable, return value, and you're trying to assign something to it. You're trying to change where in memory that array points. And the compiler won't let you do that. So we just set it up as a char star to say this is pointing to a character array. But we're going to give it its value later on by assigning it the return value from fgets. That is horribly subtle, by the way, and dreadfully confusing in most cases. But in winter term, we will be working with these things a lot and looking at the memory of the system in response to our code, and this will start to make sense. Let's see. So chat comments. So all arrays are pointers, but not all pointers are arrays. Kind of like that, yeah. Arrays are pointers, but pointers don't have to be arrays, right? And a lot of times they won't be. They may just be pointing to, you know, an integer, for example. And it's similar to this. So let's just go off the deep end here. So let's just say str is a pointer to a character. And now let's set it equal to, quote, hello. And let's print out the value of that string. All right, so str is hello. So I'm going to put in a print message here which says before the assignment statement str points to, and I'll print out the value of str with a %p. And then let's print it out after the assignment statement. And then let's print out the actual value of str. All right. Before the assignment statement, str points to null. After the assignment statement, it points to some location in memory. Okay. Where is it pointing? It's pointing to the location in memory where we find the letter H followed by E, L, L, O in a null terminator. Now, if I try to do this, right, I'll get my error. If I take out that assignment statement so that I can compile it, it tells me before my assignment statement, str points to some bizarre looking location in memory. So if I did char star str, my initial value of str was null. It didn't have an initial value. But when I say char string bracket 120, it says this is a pointer to a character. It says allocate 120 bytes of memory and set str equal to the address of that first block of memory. That's what this is. All right, so that's potentially weird. Don't forget your semicolons. So you get all those errors for like one missing semicolon. All right, so let's talk about iterating over the characters of a string. All right, so let's just go back to our simple case where we have a character array named str. We're going to use fgets to read into that string from standard in, and then let's find the length of it. All right, and now let's loop over those characters. All right, two main ways to loop in general: for loops and while loops. For loops are really reserved for the case where you know how many times you want to do something. So you have 10 things in an array and you want to do something with each of those 10 things, make a for loop. You want to read 5 lines of input from the user, make a for loop. Okay? Any other case, if you want to loop based on some condition being true or false, use a while loop. Okay? You can do it with a for loop, but don't. It will look suspicious in job interviews and so on to use a for loop as a while loop in disguise. So here we're okay with a for loop because we want to loop over each character, and we know how many characters we have. It's this variable len. So let's do for integer I equals 0, I less than len, I plus plus. Okay, and why am I doing I less than len? Because if we count our characters, right, if string length is 4, our last character is at index string length minus 1. So we want to loop to where we're less than or equal to string length minus 1, which is the same as less than string length. So you can code it either way. Got some memory question, some chat questions. I'll get to those in a moment. So we're going to loop up to and including string length minus 1. All right, and I'm just going to do a print statement here. So I'm going to say character, and I'm going to print out the value of our index variable I is, and I'm going to print out as a %c, that's a character, the element at index position I in our character array str. And then I'll just say goodbye at the end. Lots of typos. All right, so let's go ahead and run this. So enter a line hello, and it printed out 6 lines of output because there were 6 characters. HELLO and character 5, which is the 6th character, is a new line. Right? When you print a new line inside angle brackets, it breaks the angle bracket onto 2 lines. And if it says enter line and I just hit an enter, it says character 0 is, and it's just the new line. And if I do 3 spaces, then my first 3 characters were spaces, and the 4th character, character 3, is a new line. And if I happen to just hit a Control D here to signify end of file, all bets are off. Now I lucked out and I got a length 0 line, so my for loop did not iterate, but I could have gotten a seg fault, right? So in general, anytime you use fgets, you want to make sure it does not return null, so that you know that there was something that was loaded into this string. Otherwise, playing with fire, right? Could have random stuff in it, could seg fault. All right, the other thing I want to comment on in here is that the characters in this array are actually characters. So if I want to look at the character A, I can say single quote A, single quote. Okay, that's a character. It's also in some ways an integer, and character is a single byte integer, so it's a short, really short int. Whereas if I say double quote A, that's really an array. It's a pointer. It's a char star. It's a string. But it's not a character. It's actually the address of somewhere in memory where the character A has been stored. But this thing is not a character by itself. It's really a memory location. So if you're working with characters, use single quotes. So let's see if this is the letter A. So I'll say if string bracket I equals single quote A, let's print the message, I found the letter A. Alright, so I put in the input happy, happy, and it does the same loop. It shows me each letter, but each time it finds an A, it tells me I found the letter A. So that just shows us that our if statement is working correctly. Alright, that's more than enough to do ODP 413. Right? You're not going to use fgets, you're going to get this string as an argument to a function, and so it's going to be a char star, but you still put it in string length just like this, you still access individual elements just like this, you compare it to a character just like that, make a running counter, initialize it to 0, loop over the number of characters, and if you find the letter E, increment your counter. If you don't find any E's, your counter won't get incremented, you'll return 0, which is correct. If your string is empty, you won't do any looping, you won't increment your counter, you'll just return the initial value, which is 0, which is correct. Alright, so a couple of chat questions from a few minutes ago. Was the %p on string 120 twice as long as %p on the pointer? Technically, they were both memory addresses. The difference was that this address up here is in the stack. So it's got, I think, 20 or 48 bits worth of addressing. Whereas this was in a local area of storage, and so the address is much shorter. Technically, they're all 64-bit addresses, but the %p doesn't show you the leading zeros. It drops those. All right, but they're both memory addresses. But when you see a 7FF, think stack storage. We'll talk about stacks definitely in 222, maybe a little bit in this course, and when you get to like an operating system course, you'll talk a lot about stacks. We also touch on this in 270 sometimes. All right, and then the other question is the memory location allocated for *str at the size of hello once you set the value. In other words, the computer won't try to reuse the memory it is stored at. So I'm not sure I follow that, but I can say some things and see if this addresses it. So if I say something like char star str equals hello. Okay, this string itself is, you know, some hex number in memory, right? This is simply going to take this and set it equal to that number. Okay, this is not allocating any memory anywhere for a character. Is it reserved once you set the value of char star? No. So when I do this, it's declaring string to be a pointer, but it's not initializing it. When I do this, that's allocating memory, right? And that's allocated at compile time, basically, or link time, right? And then this is simply assigning str to be that address. But it's the compiler and the linker that are saying, oh, here's a string, quote, hello, let's set aside 6 bytes. find a location for it. Here's the location. And quote hello becomes synonymous with this hex address. In fact, you can go in and you can just print quote hello with a %p and you'll see the address in memory where that's stored. We're going to play with GDB in a week or two, the debugger, and we'll do some experiments like that, and that will be a useful look into how some of these things are set up in memory. Can we do a while loop and iterate over every character until we reach a null terminator? Yes. So I've been using string length to do this iteration, but there's another way, which is we know there's a null terminator at the end of our string, so we could say, you know, I equals 0 while string at index I is not equal to null terminator. And we could do the body of our loop down here, and at the end just increment I. And that's a totally legit way to iterate over a string. Personal preference. Do you want to do a for loop or a while loop? Either way is fine. But if you're going to do this, write it as a while statement. Don't say, don't put this inside a for statement. It works, but it's unconventional. So yeah, this is another good way to iterate. Follow up, because I think you mentioned something like this, but is it possible to have a string without a null terminator? You can certainly have an array of characters that does not have a null terminator. But you cannot use that with string length, string compare, printf with a %s, scanf with a %s, anything like that, right? And technically it's not a string in that case. But there's nothing wrong with having an array of characters that doesn't have a null terminator, as long as you know what you want to do with it, right? But if you hand it to an arbitrary function and say do something with this, you've got to have some way of telling it how long the string is. And that's a classic segfault setup, to not have a null terminator and then pass it to, you know, printf or something. Well, printf just keeps reading memory and says, hey, this is fun, I'm just going to print all these characters till I see a null terminator. And there may not be a null terminator anywhere in sight until you get to a memory location you don't have access to, right? Best case, you get a whole bunch of strange characters coming out on your screen. Worst case, you get a segfault. But inherently speaking, there's nothing wrong with, you know, not having a null terminator at the end of an array of characters. All right, can I do char star buffer, fgets buffer, ? Standard in? So no. So that's the whole point of fgets, is to be able to say how big our buffer is. And if you don't do that, then you basically got gets, which is the thing that says never use gets, right? But, you know, fgets, if you set aside 100 characters in a string, you can read 100 characters, and if it's not equal to a null terminator at the end, you can call fgets again to read in the next chunk of characters, and then build up a string dynamically in memory using malloc and such. That's a whole discussion in itself, but it's a pretty interesting question to run down. All right, we are beyond time, so I will leave it there. Figure out ODP 413, bring questions tomorrow. I want to go back, I want to finish talking about VI tomorrow, and then move on to some other stuff. All right, so I will see you next time. Have a good afternoon.